What is an RNN hidden state? Imagine reading a story where each new sentence depends on what happened before. That's similar to how recurrent neural networks, or RNNs, process data. They are a special kind of artificial intelligence model that works with sequences like text, speech, or time series data. Unlike regular neural networks that see each input as separate, RNNs remember what they've learned from previous inputs. This memory comes from something called the hidden state. The hidden state is like a short-term memory for the network. It is a list of numbers, or a vector, that summarizes everything the RNN has learned so far in the sequence. When the RNN processes a new piece of data, it looks at both the current input and the hidden state from the last step. It then updates the hidden state based on these two inputs. This update uses learned weights and an activation function, often called the hyperbolic tangent or tan function. This process allows the RNN to carry relevant information forward as it moves through the sequence. Think of it as the network's way of keeping track of context so it can understand the bigger picture. For example, if the RNN is predicting the next word in a sentence, the hidden state helps it remember what was said earlier. This makes RNNs very useful for language translation, speech recognition, and even generating text like ChatGPT. However, the hidden state has a limit. It is a fixed-size vector, so it can only hold a certain amount of information. As sequences get longer, it becomes harder for the hidden state to remember details from the distant past. That's why more advanced models like long short-term memory or gated recurrent units were created. They have better ways of managing memory over long sequences. In real-world applications, the hidden state is what allows RNNs to go beyond simple pattern matching. It helps them understand relationships that happen over time. This is why RNNs are used in chatbots, virtual assistants, and even in tools that generate images from text prompts. Getting a clear picture of what the hidden state does helps you understand how RNNs work and why they are so important in AI. It's also a stepping stone to seeing how models learn from data as it flows in over time. This approach raises questions about how AI systems should be built, used, and regulated, especially as they become part of daily life through productivity tools and creative applications.